Again, states of matter, 2 marks questions. State Charles law. So the relation between volume and temperature at constant pressure and number of moles. That means volume is directly proportional to temperature at constant pressure and number of moles. So volume is directly proportional to temperature at constant pressure and number of moles. That is the statement. At constant pressure, at constant pressure, the volume of given mass, the number of moles constant means mass constant. The volume of given mass is directly proportional to T. T means absolute temperature. Directly proportional to absolute temperature. So very easy. So at constant pressure, the volume of given mass of gas is directly proportional to absolute temperature. So proportionality removes V is equal to KT. So that means V by T is equal to constant. So it 2 marks. State Avogadro's law. State Avogadro's law. Here, pressure and temperature constant, the relation between volume and number of moles. So V is proportional to N at the constant temperature and pressure. So if you know the formula V is proportional to N at constant temperature and pressure, statement is easy. So at a constant temperature and pressure, equal volumes of all gases contains equal number of moles or molecules. That is the statement. At constant temperature and pressure, at constant temperature and pressure, equal volumes, equal volume of all gases contains equal number of moles, equal number of moles or molecules. So at constant temperature and pressure, equal volume of all gases contains equal number of moles or molecules. So V is equal to constant into N. That implies V by N is equal to constant. So 2 marks, very easy. Okay, next, why the gas constant R is called universal gas? Points 2 marks. Gas constant, what is gas constant? R is same. Gas constant is same for all gases. It has 1 mark. It has 1 mark. So next, it is, that means R is independent on nature of the gas. R is independent on nature of the gas. Whatever the gas taken, R is constant. So 2 points, 2 marks. So next, state Boyle's law. So again, P, V, T, N. If temperature and number of moles constant, the relation between pressure and volume tells Boyle's law. So V is inversely proportional to pressure at a constant temperature and N. So the relation between volume and pressure at constant temperature and N is called Boyle's law. So at constant temperature, the volume of given mass, number of moles constant, that means mass is also constant. The given volume of given mass of gas is inversely proportional to its pressure. Is inversely proportional to its pressure. Its pressure. So statement 1 mark, formula 1 mark, 2 marks. So V is equal to proportional to remove K by P, constant by P. That implies P into V. PV is equal to constant. So very easy, 2 marks. Okay. Which the gases diffuses faster among N2O2 CH4 why? N2O2 CH4. Which gases diffuses faster? Why? Only 2 points, 2 marks. So the first point is the rate of diffusion of gas. The rate of diffusion of gas. Diffusion of gas is inversely proportional to molecular weight. Inversely proportional to molecular weight. The rate of diffusion of gas is inversely proportional to molecular weight. Or low molecular weight gases diffuses faster when compared to high molecular weight gases. Whatever the point, the first point is the rate of diffusion of gas is inversely proportional to its molecular weight, or low molecular weight gases diffuses faster when compared to high molecular weight gases. So the second point is which one is diffuses faster? Okay, N2 molecular weight. One nitrogen atomic weight 14, two nitrogens 28, so 28 grams. So next one, oxygen O2 molecular weight. Each oxygen 16 grams, two oxygens 32 grams. Next, CH4 carbon 12, each hydrogen 1, 4 into 1 4, so 12 plus 4 16, so molecular weight is 16. So which gas is diffuses faster? CH4 gas faster diffuses faster when compared to N2 and O2. Okay, 2 marks. How many times methane diffuses faster than sulfur dioxide? We know that rate of diffusion of gas is inversely proportional to square root of its molecular weight. So rate of diffusion of methane by rate of diffusion of sulfur dioxide is equal to square root of molecular weight of SO2, because inversely proportional. Molecular weight of SO2 by molecular weight of CH4. So that implies the rate of diffusion of CH4 by rate of diffusion of SO2 is equal to square root of molecular weight of SO2. Yes, 32. Each oxygen 16. 16 plus 16, 32. So 32 plus 32, 64. 64 by molecular weight of CH4. Carbon 12. 4 hydrogens 4. 16. 16, 64 by 16. 4 times. Root 4 means 2. So RCH4 is equal to 2 into RCH4 is equal to 2 into RSO2. Means methane diffuses 2 times faster than SO2. Methane diffuses 2 times faster than SO2. Methane diffuses 2 times faster than sulfur dioxide. So 2 moles. Is why pressure cooker is used for cooking food on hills. So we know that at high altitudes, the atmospheric pressure is low. Atmospheric pressure is low. At high altitudes, the atmospheric pressure is low. The liquids boils at low temperature. So that's why the pressure cooker is used for cooking food on hills. So at high altitudes, the atmospheric pressure is low. First point, 1 mark. The second point is the liquids boils at very low temperature. So that's why the pressure cooker is used for cook food on hills. 2 points, 2 marks. To state Dalton's law of partial pressures. Very easy. If 3 vessels are taken, same volume and constant temperature. Volume constant and temperature constant. So in first vessel, 2 different gases are taken. They are non-reacting with each other. A and B, 2 non-reacting gases. In second vessel A, in third vessel B. Total pressure exerted by these gases means that is PT. Total pressure exerted by 2 non-reacting gases is equal to PT. Here the partial pressure for individual gas is, for example, P1 or PA. Here the partial pressure for gas B is PB. So what is the total pressure exerted by non-reacting gases, which is equal to, these 2 gases are individually present in that vessel. The partial pressure of A is PA, partial pressure of B is PB. So then total pressure exerted by non-reacting gases is equal to sum of the partial pressures of how many gases are present, that's sum. So partial pressure of A plus partial pressure of B, that means total pressure is equal to sum of the partial pressures of 2 gases. That is the Dalton's law of partial pressure. At constant temperature and volume, the total pressure exerted by mixture of non-reacting gases is equal to sum of the partial pressures of individual gases, Pa plus Pb. If 3 gases are present, that is, if that is C, total pressure Pt is equal to Pa plus Pb plus Pc. So very easy, 2 moles. So no need to write diagram. So only statement and Pt equal to Pa plus Pb. 2 marks question. What is Boltzmann's constant? Write its value or give its value. Boltzmann constant means K is equal to R by N. R by N, gas constant per molecule. The gas constant per one molecule is called as Boltzmann's constant. Its values are 1.38 into 10 to the power of minus 23 joule Kelvin inverse molecule inverse. Joule Kelvin inverse molecule inverse 1.38 into 10 power minus 23 or 1.38 into 10 to the power of minus 16 erg Kelvin inverse mole inverse molecule inverse erg Kelvin inverse molecule inverse. So 10 power minus 23 joules. 1 joule means 10 power 7 ergs. So 10 power minus 23 into 10 power 7. 10 power minus 16. Next one. Give the value of gas constant in different units. Gas constant is R. Gas constant is R. So its units. Okay, its units are 8.314 joule Kelvin inverse mole inverse or 8.314 1 joule means 10 power 7 ergs. 10 power 7 erg Kelvin inverse mole inverse 0.0821 liter atmosphere Kelvin inverse mole inverse or in calories 1.987 calories Kelvin inverse mole inverse. So if you write any 3 values or 2 values, you get 2 marks. Very easy. Okay, thank you. Calculate kinetic energy of 5 moles of nitrogen at 27 degrees centigrade. So very easy. So kinetic energy formula Ke is equal to 3 by 2 N or T. So 3 by 2 into N means number of moles. How many moles are given? 5. So it is 5 moles into R. R value universal gas constant. Better to take in calories. If in question there is no asking in units, then you have to take calories. So 2. R value in calories 2. 1.987. That means nearly value 2. So next temperature. Temperature already 27 degrees centigrade is given. In Celsius is given, it is converted into Kelvins. So add 273. 27 plus 273. So 300 Kelvins. So 2 cancel, 3 into 5, 15, 15 into 3, 45, 4500 calories. So very easy, 2 moles. So next, calculate the kinetic energy of 5 grams of methane at minus 73 degrees centigrade. So first converted into number of moles. Number of moles formula weight by gram molecular weight. So already weight is given 5 grams. So weight 5 by what is the gram molecular weight of methane? Methane formula CH4. Carbon 12, 4 hydrogens 4, 16. So 5 by 16. So next temperature. Temperature is converted into absolute temperature. Celsius temperature is converted into absolute temperature. So minus 73 plus 273. So that is equal to 200. Next R value. R value in the question asked in SI units. SI units for R value is 8.314 joule Kelvin inverse mole inverse. So 8.314. These values are substituted in Ke is equal to kinetic energy formula 3 by 2 N or T. So 3 by 2 into N value, number of moles 5 by 16. 5 by 16 into R value 8.314. So 8.314 into next temperature. Temperature is 200. It is nearly 623.6 joules. So nearly equal to 624 joules. Okay. Very easy. Students, in states of matter textbook problems, very important 2 marks questions. So a balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds 0.2 bar. So pressure exceeds 0.2 bar. If at 1 bar pressure the gas occupies 2.27 liters, volume up to what volume can the balloon can be expanded? So first, if 2.27 liters and 1 bar pressure, P1 is equal to 1 bar. Next, V1 is equal to 2.27 liters. Next, P2 is equal to 0.2 bar. So what is V2? So we know that pressure is inversely proportional to volume. P is inversely proportional to volume. So then different gases are taken. P1 V1 is equal to P2 V2. P1 V1 equal to P2 V2. That implies V2 is equal to P1 V1 by P2. P1 is 1 bar, so 1 into V1 value 2.27 by next P2 is 0.2. So final answer is 2.27 by 0.2. So answer is 11.35 liters. So calculate this 11.35 liters. Next, on a ship sailing in Pacific Ocean where temperature is 23.4 degrees centigrade. So that means T1, small T1 is given. It is converted into absolute temperature. T1 is equal to 23.4 plus 273. So that means 296.4 kelvins. Next, V1. V1 is equal to 2 liters air. So 2 liters. Next, T2 is equal to temperature 26.1 plus 273. So that means 273, 279, 299.1 kelvins. So V2 is equal to how much? So what is the relation between volume and temperature? According to Charles' law, volume is directly proportional to absolute temperature. So volume is directly proportional to absolute temperature. That means V1 by T1 is equal to V2 by T2. So here we want V2. So V2 is equal to V1 T2 by T1. So substitute the values. V1 is 2 into temperature T2 is 299.1 by T1. T1 is 296.4. So if you calculate value, nearly 2.018 liters. Okay.